Okay, things cut off on me, so let me just begin this video with some review of the problem. Okay, we have a boiling point elevation constant of 0.512 degrees per mole. I know that I have degrees per molal. I know that I have to determine the molality of the solution, which is going to be moles over kilograms of solvent. I have 1,000 grams, which is 1 kilogram. I have 0.5 moles of glucose. Therefore, I have a 0.5 molal solution. Now, how do I actually get the boiling point elevation? Well, what are the unit labels for boiling point elevation? What are the unit labels for boiling point elevation? It would have to be what? Degrees Celsius, right? Yes? So what would I multiply this by to cancel out molal, so I'm left with boiling point elevation? I'd have to multiply it by the molal of the solution, wouldn't I? Yes? So it's going to be 0.5 molal, sorry, the other way around, 0.5 degrees Celsius. I can do this. 0.5 degrees Celsius over molal times 0.5 molal. That cancels, and I'm left with what's 0.5, this is 0.512. What is 0.5 times 0.512? You have a calculator, or you can actually do it in your head. What's half of 512? 0.256, correct? So 0.256 degrees Celsius. So what's the new boiling point? What's the new boiling point? It's being elevated to that. In other words, the boiling point elevation. That's how you represent it. The boiling point elevation is represented there. That equals the boiling point constant times the molality of the solution. So what is going to be the new boiling point? What is it? So it'll be 100 plus 0.256 is going to equal 100.256 degrees Celsius. What is it? Is that right? Yep. That's right. So that'll be the new boiling point. Correct? So to get the new boiling point, it's the standard boiling point plus the boiling point elevation, and that's going to equal the new boiling point. Shall we write that down? Shall I write that down? I don't think it says that in the book. It just kind of like, you figure it out. But anyway, so the boiling point, we'll call it the new boiling point. Yes? Equals the boiling point standard plus the boiling point elevation. Clear? Let's do one more and then we'll quit. Okay? Yes? And I'll see you again on Monday, right? Correct? Okay. So, let's do another problem, and we'll do it over here. We'll try to leave that stuff on it. The next problem says, what is the boiling point of a 1.5 moles of sodium chloride, 1.5 moles, let me use red instead, 1.5 moles sodium chloride, correct? In 1 kilogram, correct? Now, you got to be careful of this. This is where I'm going to kind of teach you something new. What is the boiling point elevation directly dependent upon? Think. Let me ask you a question. Is it based on the number of formula units? Sodium chloride is it's not called a molecule, it's called a formula unit. Or is it based on total particles dissociated in solution? Yes? What? Maunus is thinking. He raised his hand and he's deep in thought. I love it. What do you think? I'll give you a hint. Glucose does not dissociate. Glucose does not dissociate. Does sodium chloride dissociate? Yes, it does. So how do you take into account the fact that something dissociates or doesn't dissociate? It's based on the boiling point elevation and the freezing point depression, which is the same thing but just freezing point. It's based on the total particles in solution. So let's rewrite boiling point elevation for ionic systems, okay? Can we do that? Yes? Okay. Boiling point the change in temperature, boiling point, the elevation, equals N, which is the number of ions. Number of ions. Number of ions dissociated. Okay? Yes? This is 1 kilogram solvent times the Kb times the N. Freezing point depression is the same way. Why does calcium chloride, why do they put calcium chloride on roads rather than sodium chloride? You get 50% more bang for the buck. In other words, sodium chloride dissociates to this. Calcium chloride dissociates to this. This is 2 particles, right? Calcium chloride goes like this. See that? So you've got to take into account the number of ions. It's because boiling point elevation is depending upon the total particles. Isn't an ion a particle? So it's a total particle. So if you have 1.5 moles of sodium chloride, how many moles of particles do you have? If you have 1.5 moles of sodium chloride, how many total particles do you have? 3 moles of particles. So you have to somehow make that correction. Yes? And that's what the N is for. So that's going to be 1.5, correct? So you got to multiply it by 2. You see that? Yes? What's the molality of this solution? What's the molality of the solution?
3.
Isn't it 1 point? No, it's 1.5. Right? Because it's 1.5 over 1 kilogram, correct? So it's going to be 2, that's N, right? KB is 0.512, correct? Moles, molal, kilograms, molality, degrees Celsius, right? Don't worry about the number of the unit labels. You'll get used to it. And then you want to multiply it by 1.5. So what's it going to be? What's 2 times 0.512 times 1.5? So when you do it out for me.
1.536.
What is it?
1.536.
1.536. Is that what you said? 1.536. So the new boiling point is going to be what? You get it? Now, you do the same exact thing for freezing point depression. Let me show you this, okay? And then we're done. We got 4 minutes left. All right? Easy peasy, lemon squeezy. Correct? Are you ready? Let me just show you the equation, and you'll see how it's simpler, right? So the freezing point depression is going to be the number of ions, right? If something doesn't dissociate, like glucose, then it's just 1, right? Times the KF. What's the KF for water? Did anybody find that chart in your chapter? KF for water, 1.86, right? Okay, so times KF, which is 1.86, and then you figure out the molality of the solution. Clear? So what have we done today? We have justified how solutions are formed and what factors affect that formation. We talked about molality and molarity, which are indeed representative of what? The number of particles of solute per solution, right? Correct? It's kind of like a density, isn't it, really? What's the density? What's the mass? What's the moles? What's the number of particles per unit volume? Do you see how that's a little bit like density? What would that be? How would you characterize? Give me one word that would characterize molality or molarity. Big word. I'll give you a hint. Think. I love the fact that everyone's read the chapter.
Concentration.
There you go, girl. You know, when I was a kid and I'd be sick staying home for school, there was a show on TV that you always watched, a game show. It was called Concentration. If you said the name of the host, I would get it, but God, that was like 45 years ago, 50 years ago. Can you imagine? Okay, concentration. So we talked about concentration. We talked about 2 types of concentration. We talked about molarity and we talked about molality, correct? We also talked about the colligative properties of boiling point elevation and freezing point depression. Well, actually next period I'm going to finish the chapter. Okay, so everything will be done by today. Clear? We'll have a quiz on Monday on molality, molarity, boiling point elevation. It's easy stuff. I will put the equations on the board and I will give you the data and you'll have to find freezing point depression, boiling point, molality, molarity, the whole ball of wax. Understood? Easy stuff, worth a lot of points. You can increase your grade dramatically or you can get Varied. It's your choice. Clear? Have a good one.